So now you would have you have already seen the whole setup and the kind of folder structure which are required. And now what we will do is we will go ahead and then take our images, raw files, images, and also the class files. So what we'll do is we'll do the train and test splits for our raw images, and also we create something called a class map. So that's what we're going to do next. So before we do, what we will do is I'll be running this step also on the Jupyter notebook, and then I'll also be toggling between the PyCharm editor IDE. So I'm using PyCharm. You can use whatever IDE you want. It's not necessary that you need to use an IDE like this, like PyCharm or Spider or anything. You can even run this in the terminal. I'm using PyCharm just because it's much more easier to explain all this stuff. However, you're free to use any kind of editor which you want. So I'll be toggling between the Jupyter notebook and the PyCharm here. So the first step let's to get our raw images. So this is the data folder where my raw images are kept. So you will have to change this path to reflect to where your raw images are kept. This is where all our images are kept. And now I'm just listing down all those images using this globe, using the globe method. I'm just listing all those JPG images. So this is the path. These are the paths of all the images which I have. I have got around 18 images. Now your number of images could be very different, so that's okay. So I'm just listing down. So all these images paths are inside this variable called the images. So next time we sorting this images, just to sorting these images, and then you're going to split this into train and test split. So train and test split is the specific method in scikit-learn. So using the train and test split, you have to define your specific ratio in which you're going to do your train and test split. So I've used a ratio of 10% for test size. You can use a different ratio depending on the number of images which you have. So you give the paths of these images and you do the train and test split. Now the train images and test images are the paths to the train and test images. It's not the real images themselves, but it's a path to the train and test images. So we'll see why we are doing this. So after giving the paths to the train and test images, what we're going to do is we are going to move the images, the raw images, from these paths, from the original paths, into a new folder which is inside our workspace itself. So so the next step is to create these folders, specific folders called the train, which is inside the images folder. Now if you have already created these folders manually, it is okay. So let it remain there. You don't have to you don't have to run this specific step. So let's look into the PyCharm. So what are these folders? So under workspace you have got training pothole and images, and under images you have got the train and test sets. So this step is to create those train and test folders. So if you have already created, so you can just skip this. So as I said, we'll be utilizing a utility to move the files from the origin, from wherever it is kept, into the destination folder. So our destination folder is this, is the images, train, or the test folders, which is under our workspace. So I'm here using these function, this utility function, to move those from the train images. Now train images are a split here, where we have split, where we have all these paths like this. So I'm moving these from the train images path into the destination folder, which is your workspace train. So so you have to implement this both for the train and test images. So once you implement this, then you will see this, those images are moved from your origin into your destination folder. So I've got around 16 folders here, 16 images here, and 2 images here in the test set. So that's about moving these files here. So you can I'm just listing down those those specific files in this. So next step which is involved is to do something called, or create something called as the class maps. Now for this, first you read the CSV, the annotated CSV file which we created in Post2. So now if you're wondering where this specific file is, please refer to the Post2 of this series. Here all these things are explained. So where the Post2 is, you can refer to our blog post, or whose links are given here in the descriptions in this video. So as you know, this is a data frame where you have the file name, your width, height, class, and your bounding box information. So and we're going to find what are those unique classes here in this specific file. So I have got these unique classes called pothole, vegetation, sign, and vehicles. Now your kind of unique classes could be different based on your use case or use case. Yeah, or you could have more number of classes here, or you could have less number based on how much you annotated in the original images. So all these details are there in Post2 of how you create this. So you're just taking these different classes here, and then let's switch into the PyCharm. So next what we need to do is you need to create what you call a label map. So what you do is you open any text file like this, and then copy and paste this specific steps now in this specific format. So you have an item, an ID, and the name of your class here. So this is the way you have to represent this, and then what you do is you save these specific this text file into our folder, into a folder called the annotation. So under annotations you save it under a name called the label_map.pb text. So that's a specific format in which you have to save this. So this is the one. So depending on the number of classes you have, you can save this. So you might have either more number of classes or lesser number of classes. So you represent this in this format and save it under this annotation. Now this is a specific format which the object detection API is required to create something called the test records and the train records. So both this class map along with the images, both the train and test images, are used to create this records, test and train records. Now what we will do is in the next video we'll see how we're going to create this train and test records.